Hello. In this video, we're going to be doing a couple of examples on solving a polynomial with irrational roots. So we're given the polynomial negative 10x cubed plus 15x squared plus 16x minus 12 equal to 0, and we're trying to find the solutions to this. So we need to figure out what is x equal to. In order for us to do that, we're going to try to factor this polynomial. So what we need to do first is figure out what are some of our possible zeros, because we're going to be factoring using synthetic division. So let's take a look at what are some of the possible zeros that we can check. So the way we do that is by finding our P and our Q. Remember, P represents all of the factors of that constant at the end of the polynomial. So that means we're going to have, for 12, its factors are 1, 2, 3, 4, 6, and 12. So I'm going to come up here, we have plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, and 12. Q is going to be all of our factors for the number in front. So the factors of 10 are 1, 2, 5, and 10. So I'm going to go ahead and put those down here. So, as you can see, these are a lot of possible zeros. So we would normally just go through and we would do 1 divided by 1 is plus or minus 1. And then we would do 1 divided by 2 is plus or minus a half. And then we would have 1/5, and then we would go in and say plus or minus 1 divided by 10 is plus or minus 1/10, and then we would go back here to the next number, and then we would do 2 divided by 1, 2 divided by 2, 2 divided by 5, 2 divided by 10, and we would have to do that for every single number. So it turns out that would be a total of 32 possible zeros. That's a lot of possible zeros, and we're not going to be checking each and every one of those individually. So what we're going to do is, whenever you have way too many possible zeros, we're going to use our graphing calculators. I'm using an app here so that you can see. And go ahead and graph the polynomial. That way we can get a bit of an idea of where those possible zeros are. So I see here on the left-hand side, it looks like something a little bit bigger than smaller than -1. Something a little bit bigger than 0.5 here, or looks like about 0.6, 0.5-ish, somewhere around there. And then the last one looks like it's at around 2. So those are all good clues as to what our possible zeros might be. I'm going to go ahead and guess here that 2 is almost exactly, if not exactly, our 0. So the way we're going to check that is we're going to do synthetic division using 2 here. So our polynomial has negative 10, 15, 16, minus 12. I'll bring down that minus 10 times 2 is minus 20. Minus 5 times 2 is minus 10. Gives us 6 times 2 is 12 is 0. This is exactly what we were looking for. We wanted it to have a remainder 0 because that means 2 is a factor. So that means we can take this polynomial and break that down into x minus 2. And the other part is going to be what was left over right here. So that's going to look like negative 10x squared minus 5x plus 6. Now, we could go in and pick another possible 0 and maybe do synthetic division here. But I can already see that this is a quadratic, what we're left with here in these parentheses. So we could do two things. We could try to factor this. This may or may not be factorable. I'm actually not even going to try to factor this just because of how big these coefficients are. It's not the prettiest quadratic. So I'm going to go ahead and use the quadratic formula to solve for our zeros of this quadratic here. So I know quadratic formula is the opposite of b, plus or minus square root b squared minus 4ac all over 2a. There we go. There's our quadratic formula. So this is going to help us to find the other zeros that would come from that quadratic. Because we already know that 2 is a 0, and so we're going to figure out these other ones. So what I'll do is just simplify. We have 5 plus or minus 25. That's going to be plus 240 over negative 20. So that becomes 5 plus or minus root 265 over negative 20. When I plug this into my calculator, I'm going to plug it in as two different functions. So we're going to have 5 plus root 265 over negative 20, and then we'll have 5 minus root 265 over negative 20. And these are irrational numbers, meaning they're not going to be able to square root and divide and give you a pretty number. So when you plug it into your calculator, we're going to get approximately negative 1.0, I'm not going to fit, 0.639. And this one is going to give us approximately 0.563, squeeze that in there. Okay. So those are your other two zeros here. So we were trying to find all of the real solutions. All of our real solutions are x equals 2. X is approximately negative 1.0639, and x is approximately 0.563. Those are all of our solutions there. We can do one other thing and recall Descartes' rule of signs. So if we see here, it's going from negative 10 to positive 15, so that's one change. And then it's going from positive 16 to negative 12, that's another change. So that means that we're going to have 2 or 0 positive solutions. And if we look at our solutions here, we have 2 positives there. So that's a nice check. If you go ahead and plug in negative x into this function, you'll see that there's only one change in sign when you do so, and so then you'll see that there's only going to be one negative 0, which checks out. So that is our solution there. If we go back to our graph, I can see my negative 1 right there, negative 1.06. And then I have my positive 0.5639 right in there. And there you have it. There's our first example. Our next example, very similar. So I'm going to go ahead and find all of my possible zeros. which means I'm going to take P and Q. P is all of the factors for this one, which will be 1, 2, 7, 14. So we have plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. All over, coefficients here are, factor here is just 1. So we'll have plus or minus 1. So you see we have a bit more of a reasonable possible zeros. We're going to have plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. So we're just taking each of these and dividing it by 1. So nice and easy. We have 8 possible zeros here. Why don't we, while we're at it, go ahead and use Descartes' rule of signs to see if we can maybe narrow this down by anything. I see that there's one sign change here, another one here, so that means we're going to have 2 or 0, positive zeros, and let's see, if I plug in a negative here, negative there, this will become negative x cubed minus 7x squared plus 11x plus 14. That means we only have one sign change here. So we're only going to have one negative solution, or one negative zero. Narrows it down a little bit. We'll just keep that in mind. Why don't we just go ahead and try some of these possible zeros and see if they work. So I'm going to start out with 1, since positive 1 is a possible solution here. And I'm going to do synthetic division. Let's see what our original was here. We have 1, negative 7, negative 11, 14. Bring down the 1. That's going to give me negative 6, negative 17, and that gives me negative 3. Negative 3 is not 0. That means that 1 is not a possible solution, or is not a solution. It was a possible one, but now that we've checked it with synthetic division, we did not get a remainder 0, so 1 is not a solution. We can try negative 1. So here we go again. Oh, that's all my terms. Am I missing any? I am missing one. I'm missing 1. 1, negative 7, negative 11, and positive 14. Bring down the 1, negative 1 gives us negative 8, positive 8, negative 3. That's going to be a positive 3, which gives us 17. So then we know negative 1 is also not a solution. Let's check one more before we decide to maybe graph it. We're going to check 2. So actually, let's check negative 2. So we're going to do this again, set up our polynomial, bring down the 1, negative 2, we get negative 9. Negative 11 plus 18 is going to give us 7, and we got a remainder 0. Yes, I picked negative 2 on purpose. I knew it was going to be a 0, and there we go. So negative 2 is one of our zeros here. So that means we can factor this. We have x plus 2. That's what we get from this 0 here. Think opposite when you write it as a factor. And it's going to become x squared minus 9x plus 7 there. This is not going to be factorable. I can already see here the only factors of 7 are 1 and 7, and there's no way of getting 1 and 7 to add up to negative 9. So I'm just going to use the quadratic formula right away. And I know x is going to equal the opposite of b plus or minus square root b squared minus 4ac all over 2a. There we go. So 9 plus or minus 81 minus 28 over 2 equals 9 plus or minus root 53 over 2. Again, that's going to split up into two equations here, two parts. So this is going to be approximately 8.1401 when I plug it into my calculator. And this one's going to be approximately, so 9 minus root 53 over 2 is approximately 0.8599. And those are my additional two solutions that come from that quadratic. We already knew that this one was -2. So all of our solutions are -2 and x approximately 8.1401 and x approximately 0.8599. We can double check with Descartes and see if we got that right. Yep, we have 2 positive zeros and 1 negative. So there are our solutions that we can find when we have irrational roots. So meaning we end up with this irrational decimal there because of the root that we got in our solution. And that is the end of it.